Hello, hi to everyone. Next, we are moving to the second lecture from the transistor characteristics and approximations. Okay, so in this particular topic is different ways of drawing transistors. So still now we know common base, common emitter, common collector characteristics. From that, how to draw the complete circuit diagram, complete transistor diagram, we'll see in this particular topic. So first one, we'll look at common base. So common base configuration, how to draw the circuit. So in this common base configuration, the base terminal is common to both input and output. Let me take for example, this is a PNP transistor. PNP transistor. Everyone clearly listen. In case of PNP transistor, the middle letter N is represented negative. This negative means collector as well as base both are negative with respect to emitter. Clear? In case of PNP transistor. That means what about the potential polarities of this particular PNP transistor? It is a collector is more negative, that's why double minus, as well as base is negative, only one minus. So it is a positive. So this is the polarities of the common base configuration for PNP transistor. This is the way need to identify the polarity. So after that, these are the voltages we are connected VVE and VCE. You know that transistor, if you operated the transistor properly biased, the input should be forward bias and then output should be reverse bias. The input is a forward bias means, this is a PNP transistor. It is a forward bias. When it is a forward bias, P is connected to positive. Thus, then only it is a forward bias. Yes, got it. Coming to the second case, negative terminal is connected to P, then only it is a reverse bias. So the input is a forward bias as well as the output junction is reverse bias. That condition is also satisfied. So this particular diagram I am going to represent it. VVE is a plus 10 volt and VCC is a minus 25 volt. Got my point? Those are connected to emitter and load or collector resistance, as well as base is connected to the ground directly. The notations are IE current, IC current, as well as IB current. VBC, VEB, these are the voltages we have. Clear? And this is about the common base configuration notation. In the same case, in case of common emitter, we are taking NPN transistor in this case. We'll look at. So this P is represented positive. What are the terminals are positive? See here. Collector is more positive and base is positive with respect to emitter. Emitter terminal is a negative. Okay, that is about the polarity. All of you clearly understood? So based on this, don't by heart it. I will give the logic here. In case of NPN, what is the middle letter P? The middle letter P means that positive. It is a positive collector as well as base. Both are positive with respect to emitter. Okay, in this particular case. Again we can check. This is a way to draw the diagram. Plus VBB plus VCC RB RL as well as emitter, and then it is a VBE, it is a VCE. So in this particular case, it is a NPN transistor. The input should be forward bias as well as output should be reverse bias in the normal working condition. So how it is a forward bias? N is connected to, it is a NPN transistor. N is connected to negative. But here some mistake is there. It is negative and positive. So minus VBB. So it is minus VBB. It should be negative and positive. Okay. Coming to here, this N terminal should be connected to positive. Then only it is a reverse bias. Yes, it is a reverse bias. So that condition is also satisfied. This is the way to draw the diagram for common emitter configuration. Coming to the once your common emitter configuration, last one common collector configuration. So common collector CC. In the case of common collector configuration, collector terminal should be common to both input and output. Here also it is NPN transistor. NPN transistor. So this is the inside is a P terminal. Emitter as well as collector. Emitter and base should be positive. Emitter is more positive compared to base, and just one second, I will repeat. Okay, fine. Base is a positive and the collector is more positive, that is a double plus with respect to emitter. That means emitter terminal is a negative. Again, it is a forward bias. It is an NPN transistor. Okay. First terminal negative is it is a negative is connected here, and positive it is a forward bias condition. Next here NPN positive is connected is reverse bias condition. This is a condition to in the normal working condition. So again, to draw this particular diagram equally, IB, that is a current here, IE, this is a current here, as well as NPN transistor, VCB, VCE. Okay, this is a way to represent the common collector configuration. All three cases, this is a representation for the diagrams of common emitter, common collector and common base. Now we are moving to common base formulas. Common base. So just look at this particular diagram. I am going to derive some formulas to you. So those formulas are, the first formula will be related to the emitter current. So first formula should be emitter currents. Look at this particular diagram. So I want to find out the emitter current. I can apply the KVL in this particular loop. So that value will be negative to positive, right? So VEE. Next here minus IE RE. IE RE. Just one second. IE RE small. Okay. Again, it is a VEB minus VEB is equal to 0. Okay. From that, how to find out IE, that is emitter current, IE is equal to VEE minus VEB divided by RE. This is a formula for emitter current. Clear? In this particular circuit, from this particular circuit only, I gave that formula. After that, second formula will be base current. Once you know emitter current, alpha definition. Alpha is equal to IC divided by IE. From that, IC collector current is equal to alpha times of emitter current. This is a formula for second on the common base configuration. Third formula you need to remember, VBC, the base, this particular voltage, that is a VBC. How to find out the VBC? So VBC is equal to VCC minus RL into IC. So IC into RL, that is a voltage drop. Okay, that is approximately IC approximately equivalent to IE. Some cases if they mention IC approximately to IE in case of it is mentioned intentionally in the problem. Okay, neglecting the particular cases. This is about the common base formulas. Everyone is clear about the common base formulas. Now we are look at into the one example. Then we are moving to the another problem. The problem here in the circuit shown in the figure, what value R and the cause of VCB is a 5 volt. They provided VCB. They are asking about the RL. Very simple. VCC is equal to IC into RL, this particular voltage drop, plus this particular voltage VCB. Okay, just now we derive that VCC. Just see here. You want VCC is equal to VBC plus ICRL. The same formula I am writing it here. Yes or no? Okay, once you know KCL and KVL, you can play with the transistors. You can play with any circuits, whether transistor or FET, CMOS or any device. If you clearly understood the KCL and KVL. Just know in the first chapter we discussed the more videos on that. So I don't want to repeat once again those all the basic concepts. Just look at here. So you got what you want? RL. So from RL is equal to VCC minus VCB divided by IC. Right. So what is a VCC? Is given 20. VCB is a 5. What about the IC value? So IC value we need to find out. So first how to find out the IC? First IE is equal to 10 divided by 10K. This is the IE. That IE value is a 1 milliamperes. Once you got IE value is a 1 milliamperes, IC is equal to alpha into IE. Right. So alpha I can take, they didn't mention any value. Alpha I can take approximately 1. Then IC is equivalent to IE, that is a 1 milliamperes you can take directly. So 1 milliamperes. So from that it is a 15, RL is equal to 15 kilo ohms. That is a RL value. Everyone clear about the solution? Okay. Next, we are moving to the another example problem. Then we will get the complete idea about the solution. So for circuit shown in the figure, find the value RE. Where is RE? This is the RE. Causes to VBC is a 10 volt. So you want to find out the RE. The formula here RE is equal to, so RE is equal to 20. Here 20 is there. 20 divided by IE. So you want to find out the RE, you should find out the IE. So how to find out the IE? So IE is equal to IC divided by alpha. So alpha it is mentioned anywhere? No. You can take alpha is very small, it is nearly equal to 1. It will be IE approximately equivalent to IC. So finally what I need to find out, if you want IE, IC I can find out. So look at here. How to find out IC? IC is equal to VCC, that is a 20 volt. Right? 20 minus, what are the voltage here? 10. 10 divided by, what about the resistance? 20K. So from that it is a 0.5 milliamperes. So therefore RE is equal to 20 divided by 0.5. Because both are approximately equal, it will be 40 kilo ohms is the answer. It is a 40 kilo ohm. Then we are moving to the common emitter formulas. Okay. So just look at here. With the help of this particular diagram, we are going to write the formulas. So first formula I am going to write. It is a common emitter. Emitter is a common. IB, the base current. This base current formula, IB is equal to VBB, that is a VBB minus VBE, okay, divided by RB is a formula for IB. In the most of the cases, VBE is a neglected. Ideal cases, VBE is a neglected. It is approximately equal to VBB divided by RB. If it is VBE is a neglected. The values are depending upon if it is silicon, it is a 0.7. If it is germanium, it is a 0.3, that BBB value. Otherwise, you can take it as a neglected until unless they mention. After that, IC, how to find out the IC with, if you know the IB, beta into IB, this particular formula. Next, VCE, third formula is a VCE is equal to VCC minus ICRL. IC into RL. These are the three formulas we have. With the help of that particular formulas, we are going to study the next problem. And the problem here, find the exact values of emitter current IE. Find the exact values of emitter current IE in the two supply emitter bias. Here, how many supplies? Two supplies emitter bias shown in the figure. Okay, what they are asking, IE current. So IE current is a emitter current. Here two supplies here given. So in that particular case, we have to do that. The first thing, IB. Now IB value is VBB divided by RB. That formula just now. Whatever the VBB it is given. Look at this particular problem. So here, not in the previous problem, this problem we are going to see. For the circuit shown in the figure, find the IB, IC and IE. These three parameters, and then fourth one VCE. The first parameter is IB. IB is equal to VBB divided by RB. What is a VBB? 10 divided by what is RB? 1 milli. 1 mega ohm. That will be 1 mega ohm. That will be equivalent to 10 microamperes. You got it. Okay. We are neglecting the VBA. They mention intentionally neglect the VBA. Second case, IC. IC formula beta into IC is equal to IC is equal to beta into IB. Okay. In case of beta value, it is mentioned the beta value is 100. It is mentioned. So beta is equal to 100 into whatever the ID you got, 10 micro. That will be equivalent to 1 milliamperes. Got it. The third case, IE. IE is equal to emitter current. IE is equal to IB plus IC. What about the IB 10 micro? IC 1 milli. That will be equivalent to 1.01 milliamperes. The fourth one is a VCE. So VCE is equal to VCC minus IC into RL. IC into RL. VCC is equal to 15 IC into RL. IC is a 1 ampere. Okay, 1 milliampere, and RL is a 10K. That will be equivalent to 5 volt. Okay, that about the solution. So this is the way in the examination. So don't panic in the examination if they provided this type of circuits. You know everything because you are attending my classes, right? Once you attending my classes, you can 100 out of 100. Once you completed the syllabus of all 5 units, we have a confident about 100% surety is there. We'll get 100 out of 100 in the technical section. In the non-technical sections also, we are providing some test series and everything. We can score more than 140 marks out of 180. You will be in the list of interview list they will provide it. Definitely we are in the list of interview. So everyone is be positive and then prepare well. Okay, next we are moving to the another problem. Before that, I am going to give some important shortcuts to you to find out this type of circuits easily. Okay, that is a beta rule. First understand the beta rule, then we are moving to the remaining topics. So beta rule is a very simple. The first point you need to remember, when RL, that is a load resistance, RL or RC, that is a load or collector resistance, referred to, that means same as transformer referred to primary and secondary side, this same concepts here also referred to base circuit. It is multiplied by beta multiplication. Okay, that is the first point. Second point, okay, when referred to the, so same thing, whenever referred to the collector circuit, the same thing, it is a base circuit. Whenever referred to the collector circuit, okay, collector circuit divided by beta. Okay, that is the first point. Second, Re, that is the emitter resistance, referred to base. It is multiplied by 1 plus beta, or approximately beta. That is the first. Second, third one, similarly Rb, that is a base, is referred to emitter circuit. I will explain with the help of the problems. You will get the idea. Just remember these concepts. Rb referred to emitter circuit, it is multiplied by 1 plus beta or beta based on that approximation you are taking. So let us take that particular these three conditions with the help of this example. Okay, the first example, calculate the value of VCE in the collector stabilization circuit. Okay, right. I want to find out the VCE. How to find out the VCE? See here. VCE is equal to VCC minus IL into IC into RL. Got my point or not? So VCC is known value, RL is a known value. What is unknown value here? IC. IC is unknown value. How to find out the IC? We'll see. So I want to find out the IC. IC is equal to beta into IB. But IB value? You don't know IB value. You want to find out the IB value first. So then IB is equal to the formula. Look at here. VCC, that is a VCC divided by RL. RL I am consider very important. I am consider the current path of IB. I am going to apply the rule. Apply the equation. Yes or no? That means RL referred to base circuit. Just see here. RL or RC referred to base circuit. What will happen? Multiply with beta. Yes or no? That means RL multiply with beta. So that will be RB plus beta into RL. Then it is easy to got my point. So that is a formula. So from that, what is a VCC 20? What is a RB 1K? What is a beta? The beta value, it is mentioned 100, right? The beta value is 100. It is mentioned that. So 100 into RL is a 10. Then it is a IB value is a 10 milliamperes. Once you got the IB value, it will be substituted here. 100 into 10 milli, that will be equivalent to 1 ampere. Once you got the IB value, IC value, then therefore VCE is equal to finally VCC 20 minus IC 1 ampere into RL is 10. That will be equivalent to 10 volt. It's a very simple. So everyone have to following or not. So beta rule, if you are applying the beta rule, if you remember these three shortcuts formulas, you can substitute here, you will get the answers. Let me take another example. I will explain the better way. Okay. Calculate the 3 transistors currents in the circuit. 3 transistor currents are emitter current, base current and collector current. We have to find out. So first of all, I am going to find out the base current. Okay. So how to find out the base current here? This is a base. IB is equal to VCC. I am going to write the formula VCC divided by. You should understand IB I am taking, this is the direction. But in the same path of IB, RE is present or not. If your RE refer to the base circuit, if your RE refer to the base circuit, what we have to do here? RE referred to the base circuit, you can multiply with 1 plus beta or beta based on the approximation you have considered. So in this particular case, RB plus beta into RE. Okay, beta into RE. So I can know 10 divided by 100k plus beta is given 200 into 0.5 is a 0.5k. That will be equivalent to 0.5 milliamperes is the answer. That is a base current. Next, coming to the collector current, IC is equal to beta into IB. That is a beta 200. IB is a 0.5 milliamperes. That will be equivalent to IC value equivalent to 10 milliamperes. Okay. Next, finally, IE is equal to, this is the second current, right? Third current have IE is equal to IB plus IC. IB is at 0.5 milliamperes plus 10 milliamperes is the IC, that will be 10.5 milliamperes. 10.5 milliamperes. 10 point, it is not 0.5, it is a 0.05, 10.05 milliamperes. Okay, that is about the solution. Okay, one more problem you have to look into that. Then we will get the complete idea about the beta rule. So here in this particular case, calculate the IE in the circuit. Where is IE? This is the IE, right? So IE is equal to the formula. IE is equal to VEE, that is a voltage VEE, divided by RE plus. In this particular case, I am going to apply this particular IE value in terms of this is a path I have to apply. So this is the path I am going to take, that RB referred to emitter circuit. This RB referred to the which current you are consider now? IE current. IE current. That's why RB referred to IE. What is the formula? We have to do that with alpha of the three cases. So in the first particular case, in this case, base current, the base resistance, that is a RB referred to emitter circuit. RB referred to emitter circuit. Referred to emitter circuit. It is divided by, right? Divided by 1 plus beta or beta. Okay. So everyone clear about those notations. So RB divided by beta I am going to consider. Got my point? So 10 divided by 10k plus beta. What is the beta value? It is given. Beta value is provided 100. Here given 100. 100 divided, RB is a 10k divided by 100. That will be equivalent to 0.99 milliamperes. You got the answer. So this is about the emitter current. So this is about the all the relations with respect to beta values. Okay, now come back to the problem number, common emitter configuration problem. So they are asking about IE, IB and IC and VCE, neglect the VBE values. Beta is 100. So first of all, I am going to calculate first IE. I gave the beta rule to you. How to find out the IE? IE is this is a particular current I want. So that is a VEE divided by RE plus this base resistance referred to emitter. So that is a RB divided by beta. Just now I gave that formula. Very simple. This three once again I will revise those three formulas. Very important. We can do any problem with alpha of that. RC referred to, that is a collector current, collector resistance referred to base, it is multiplied. Similar case, collector resistance, that is a base resistance referred to collector divided by. Again, emitter resistance referred to base, it is a multiply. Base resistance to emitter divided by. Okay, opposite. So this is the formula I have. So finally VEE, that is a 30 divided by RE is a 30K plus RB, base resistance 20K divided by beta. What is the beta value is given 100. Okay, beta mentioned 100 in this problem. So finally we'll get IE value is of 1 milliamperes approximately. Okay, second one, IB, base current one. Base current IB is equal to, emitter current divided by beta. Base current is equal to emitter current divided, because of IE is equal to beta into IB. So from that, what is the IE value got? 1 milliampere. What is the beta? 100. That will be equivalent to 0.01 milliamperes you got. Okay. Next, third one, IC. IC is equal to IE minus IB. What is the IC minus IB? 1 minus 0.01, that is a 0.99 milliamperes you got. So you got IC also. After that, last one, VCE. You're asking about VCE. So VCE is nothing but a voltage across here. VCE is equal to, VCC minus IL into RL. IL into RL. IC into RL. Okay. So that will be equivalent to 30 minus 10 into 0.99. That will be equivalent to 20.1 volt. Because it is a two sides we are given the supply, it is not grounded. We are taking up to VCE up to here only. So this is about the VCE value. This is about the solution. Okay. So next we are moving to the common collector formulas. Okay. This is a circuit of common collector. Okay, this is a circuit of common collector. The output taken from the here common collector, it is the input. So I will give the formulas directly. IE, emitter current. This emitter current IE is equal to VCC, that is a VCC minus VBE, that is a base to emitter voltage, VBE divided by RB divided by RE. This is the RE plus this emitter resistance, this base resistance referred to emitter, that is a RB divided by beta. This is the formula for IE, emitter current. Next, VCC is equal to VCE plus IERE. VCC is equal to VCE plus IERE. In the case of emitter is grounded, output here taken here. That is about IE. Next, IC is equal to beta into IB. IC is equal to beta into IB. Those are the three formulas you need to remember. So with the help of the problem, we are going to discuss about this particular common emitter configuration, common collector configuration. So here collector terminal is a common to both input and output. So first they are asking about IB. I am going to find out the IB first. IB is equal to, IB, this is the current. This is the current, IB. That is a VCC minus VBE divided by RB, resistance RB, plus emitter resistance referred to base 1 plus beta into RE. So that will be VCC is a 9 volt. Okay, it is given. Minus VB is a 0.7. It is given. It is a silicon. RB value is 100K plus 1 plus beta, that is a 1 plus 49 into RE value is a 2K. From that IB value here 41.5 microamperes is the IB value. So next bit B. The B bit, IE value. IE is equal to 1 plus beta into IB. You know that formula. So from that 50, 1 plus 49, 50 into 41.5 microampere, that will be equivalent to 2.075 milliamperes. Next, C bit, that is a VCE. They are asking. VCE is nothing but a VCC minus IERE. VCC minus IERE, outer loop. So VCC minus IERE, that is a 9 minus IE into RE. 9 minus, what is the IE value? 2.075, RE value is 2K. It is a milli. That will be equivalent to 4. VCE. That will be equal to 4.85 volt. Next, they are asking about VE. D is a VE. VE is equal to IE into RE. What is IE? 2.075 milli into RE. RE value is a 2. That will be equivalent to 4.15 volt. At the last, E bit. VB they want. VB is nothing but here. VB is equal to VBE plus IE RE. Here VBE plus, that is a base to emitter voltage, that is in silicon 0.7, germanium 0.3. But here 0.7 is given. IERE value is a 4.15. Just we got it here. So from that 4.85 volt. Okay, this is about the problem related to this particular common collector configuration. Okay, so up to this we completed the beta rule and then common emitter, common collector formulas, and then problems related to everything. Then we are moving to the very important concept. You may expect one question from here: importance of VCE. Okay, so what exactly the VCE importance? So you can, while you are testing the transistor, we can test the VCE. If VCE, whether we are checking the VCE, you can identify the transistor is a defective or working in cutoff or working in saturation or well into saturation. These 3 points you can identify with the help of this particular VCE. So after testing, we can find out first one, defective or not. Defective or not, we can find out. The second one, working or cutoff, that is off state. So we can also identify. Third one, saturation or well into saturation. These particular points you can identify. So how identify, we'll see. I will give the 3 important relations everyone remember. For example, VCE is equal to VCC. Both are same. That particular transistor in the cutoff state, that is off state, that is a cutoff. Cutoff is nothing but a off state. Okay, whenever VCE is equal to VCC, both are equal, transistor is off state. The second thing, for example, VCE is equal to 0, that is a case of saturation. That means it is a turn on state. Third one, VCE is negative. VCE is negative, less than 0. It is a negative, so well into saturation. Okay, these are the 3 conditions we have to identify. Whether in the examination they will give the problem and then identify whether transistor is a which state, saturation, cutoff, and then saturation, cutoff, as well as active state. We can identify that. So with the help of the problem, we will do that. That particular problems related to. Okay, first problem, for VCE of the circuit, find the value of VCE, beta is equal to 100, neglect the VBE, transistor working in cutoff or saturation. Transistor working in cutoff or saturation. So look at here. How to find out cutoff or saturation with help of the VCE. So VCE is equal to, so we'll do the problem. VCE is equal to, how to find out the VCE? This is the VCE, VCC minus IC into RL, VCC minus IC into RL. So from that, VCC is a 10 minus IC into RL is a 1 into IC. You don't know IC value. First find out the IC value. So IC value, how to find out the IC value? IC is equal to beta into IB. So beta value is given or not? Yes, given. So IB value you need to find out first. So IB, how to find out the IB? Very simple. IB is equal to 10, that is a VCC divided by resistance RB 100. There is no resistance in the emitter, don't consider here. So that will be equivalent to 10 ampere, IB equivalent to 0.1 ampere. 0.1 ampere. So finally IC is equal to beta 100 into 0.1, that will be 10 amperes. That will be 10 amperes. Multiply here. 10 minus 1 into 10, that will be equivalent to 0. So you know VCE is equal to 0, then we can call it as a saturation. So particular transistor working under saturation. Okay, clear? Next, coming to the next problem. In the next problem, find out whether transistor working in saturation or well into saturation. Neglect the VBE. So they mentioned VBE is neglected. Again, we need to find out VCE. The same thing. VCE. VCE is equal to VCC minus IC into RL. You know, I want IC. If I want IC, first I'm going to find out the IB. So IB is equal to 10 divided by 10. That is a 1 ampere. Because you neglect the VBE as well as there is no resistance in the emitter terminal. So IB is a 1 ampere. From that, IC is equal to beta into IB. You know that formula. What is a beta? 100. Yes or no? What is a beta is given? 100, right? Into 1. That is a 100 amperes. So now finally VCC, that is a 10 minus 100 into RL. RL is a 1. That means it is a minus 90 volt. Whenever it is a minus 90 volt, whenever minus is taking place, I give the 3 statements here. Whenever it is a less than 0, minus value, well into saturation. So now in this particular case, transistor well into saturation. Well into saturation. Okay? This is about the problem. Next, we are moving to the cutoff and saturation points. Cutoff and saturation points. So we will see from the diagram here. Once we are cutoff and saturation, how to find out? See, VCC, for example, VCE is equal to VCC minus IC into RL. IC into RL. In this particular case, the base current is equal to 0, collector current is equal to 0. Whenever collector current is equal to 0, VCE is equal to VCC. VCE is equal to VCC. That's what you call it as a saturation. This condition here, whenever both are equal, IC is equal to 0, then it is called it as a cutoff state. Cutoff state, whenever both are whenever both are equal. So in this particular case, VCE, you are call it as a VCE cutoff. Okay, cutoff state. We can also mention that. Next, second case. In case VC is equal to 0, this is the case, IC is equal to 0, that is a cutoff state. Next, coming to the VCE is equal to 0. Whenever VCE is equal to 0, what is the state? VC is equal to 0, saturation. So saturation points, how to find out with help of this diagram, with help of this equation. 0 is equal to VCC minus ICRC, RL or RC, no problem. From that, IC is equal to VCC divided by RL, that is a saturation current. In that particular case, IC we are call it as a saturation current. This is a condition we are call it as a saturation. Okay, that is a cutoff. This one is a saturation. So with help of that, we are going to take one problem based on that cutoff and saturation. We will end up this particular video. So in this particular case, in the simple amplifier, okay, shown in the figure, base resistance RB is a 50 kilo ohm and RE is a 2 kilo ohm emitter resistance and RC is a 3 kilo ohm. VCC is a 10 volt. It is given, right? And HFE, that is a parameter forward. HFE is nothing but the gain. Okay, gain, that is a beta. We can take it as a HFE. Indirectly it is mentioned HFE is nothing but a beta, gain, current gain. So determine the whether it is determine whether or not the silicon transistor is in the saturation, and find IB and IC, explain the saturation region in common emitter characteristics. This is about the problem, but you are attending the objective exam. I will straightforward, I am going to explain what is required in the examination point of view. So whether it is a saturation or not, we have to identify. So if you want to identify whether saturation or not, you need to identify whether VCE value. So first of all, you want to find out the VCE. So if you want to find out the VCE, what are the parameters is required? First look at here. To find out the VCE, first write the formula VCC minus VCC. For example, VCC is equal to IC into RC plus VCE plus total entire IE RE in this particular case. Clear? Now, you know VCC is a 10, right? IC you want to find out, VCE you want to find out, okay, RE you don't know, you want to find out IE. So all these parameters one by one let us find out. First I am going to find out IE. How to find out the IE emitter current? This particular emitter current IE is equal to VBB minus VBE divided by the resistance RE plus, where base resistance referred to emitter. Beta rule I explained already. RB divided by beta. Okay, that's what here VBB. What is the VBB value? So VBB value is the 5. Just verify the what about the VBB value. So here VBB value is a 5 volt. It is given. 5 minus VB is neglected. For example, it is silicon, we can take it as 0.7, but it is not mentioned in the problem. So divided by 2 plus 50 divided by 100. What is a 50k divided by 100? That will be equivalent to 2 milliamperes. You got my point? Okay, right. It is also 2k. Once you got the IE value, next IC. IC approximately equivalent to IE. So that is a 2 milliamperes only can consider. Next IB. IB is equal to IC by beta, you know that. What is the IC? 2 milliamperes by beta is a 100. That will be equivalent to 0.02 milliamperes. 0.02 milliamperes. Once you got all the currents, once you got all the parameters, finally VCE you want, right? VC is equal to VCC minus, that is a 10 minus IC, that is a 2 into 3 minus 2 into 2, all are milli. So that will be 10 minus 6 minus 4, that will be 0 volt. It is a kilo, it is a milli, it is a kilo, it is milli, both get cancelled, you will get 0. Whenever Vc is equal to 0, what we call it as a Vc is equal to 0 is nothing but a saturation region. So saturation. So transistor into the saturation. So this is about the complete explanation about the transistor saturation, cutoff, and then formulas, and then beta rule. This particular video is a very important. Okay, thank you.